to the online learning SMPK PENABUR Jakarta. Hello students, how are you? I hope all of you in a good condition right now. Today we are going to continue our learning section on the topic of thermal expansion, and especially through the video we will learn about solid expansion. The basic competence of this lesson is 3.7. Understand the concept of temperature, expansion, heat transfer, and their application in the mechanism of maintaining body temperature stability in humans and animals in daily life. And 4.10. Conduct the experiments to investigate temperature and its change and the effect of heat in temperature and state change. The Christian values of this lesson is perseverance, never give up, and do your best. What is thermal expansion? In physics, thermal expansion can be defined as the change in length, width, height, or volume of any material on changing the temperature. Thermal expansion divided by three types: expansion of solid, expansion of liquid, and expansion of gas. For expansion of solid divided by three types: linear or length expansion, area expansion, and volume expansion. And for expansion of liquid only has volume expansion, and expansion of gas only has volume expansion. In this video, we will investigating the thermal expansion in solid and especially in length expansion. Why are gaps left between railway tracks? Look at the yellow circle. During the day, the railroad gap close each other. At night, the gap is away each other. Look at the picture. At day, the railroad gap close each other, and at night, there is a gap between the railroad connection. Why motorcycle turn signal can blinking when we want to turn left or right? Why, if temperature is very high, then the iron will turn itself off and there will be a thick sound. If the temperature is low, the lights turn on again. Why the electrical cable from one pole to another is made loose? Why there is a gap between window and its frame? We can answer all of the phenomena after we learn about length expansion. Linear or length expansion. The increase in length of an object because it receives heat. The magnitude of length expansion depends on three factors. 1. The initial length of the object, or L0. 2. Change in temperature, or delta T. 3. The coefficient of length expansion, or alpha. Look at the illustration of length expansion below. L0 is the initial length, LT is the final length, and delta L is the increasing of length. can write in equation of length expansion become delta L equals to alpha times L0 times delta T. It means the change in length of solid material when heated or cooled is equal to the length expansion coefficient for that material multiplied by initial length multiplied by the change in temperature. For example, if the initial length of copper is 100 cm and then the copper heated until 100 degrees Celsius, so the final length is 100.17 cm. So delta L is the additional length from 100 cm copper if heated until 100 degrees Celsius. So delta L is the additional length from 100 cm copper if heated until 100 degrees Celsius. And alpha or coefficient of length is additional length for 1 cm of substance if heated 1 degree Celsius. We can write the formula of coefficient length expansion is LT minus L0 divided by L0 times delta T, which delta L is change in length, the unit is meter. Alpha is the coefficient of length expansion, the unit is per degree Celsius. L0 is the initial length, the unit is meter. LT is final length, the unit is meter. And delta T is the change in temperature, the unit is degree Celsius. Now, we can find the final length of substance after heated from the formula of coefficient length expansion. Alpha equals to LT minus L0 divided by L0 times delta T. LT minus L0 equals to L0 times delta T times alpha. So LT is L0 times delta T times alpha plus L0. So to find the final length of substance after heated is LT equals to L0 bracket 1 plus alpha times delta T, which LT is final length, the unit is meter. One of the tools that use the concept of expansion is bimetal. A bimetal of thermostatic metal is a sheet or strip of two or more composite materials having different coefficient of linear thermal expansion bonded by riveting, brazing, or welding. Bimetal will be bent towards a smaller coefficient of expansion. Summary: solid expand when they are heated and decrease in volume when they get colder. From a microscopic point of view, the result of heating a material can be explained as follows. There is an addition of energy to the material. The internal energy of the atom of the material increase, causing atom to vibrate. The vibrating atoms now occupy more space when hot compared to when cold. Now, after we learn about length expansion, we can answer the phenomenon of expansion based on the concept of expansion in daily life. Why are gaps left between railway tracks? On a hot day, the metal expands, and if it was not allowed to do this, the rails would bend out of shape. This phenomenon can cause a railway accident. Why motorcycle turn signal can blinking when we want to turn left or right? The motor turn signal may turn on and off because it is separated or connected to the contacts due to the movement of bimetallic strip. Next, why if the temperature is very high, then the iron will turn itself off and there will be a tick sound? The metallic electric iron functions as an automatic temperature switch that will break the electrical contact if the iron temperature is very high. The electrical cable from one pole to another is made loose. This is because at night or lower temperature, the cable doesn't break. The The installation of window glass is usually given space in the frame. It is usable if the glass expands during the day. If we don't use the gaps, when the glass expands, it can break. Now, exercise. Why pouring hot water in the picture on the side, making it easier to open the bottle? The answer is because the metal conducts more heat than the glass. This means the metal will expand before the glass gets the chance to expand the same distance. So as the metal expands, the force required to open the bottle decreases. Number 2. To make it easier to install train wheels, what we have to do is A. Heating the wheels, B. Heating the axle, C. Widen the wheel hole, D. Reduce the axle. And the answer is B. Heating the axle. Number 3. The phenomenon that do not use the principle of expansion is A. Installation of window glass, B. Railroad connection, C. Steel nails in the wall, D. Iron bridge connection. And the answer is C. Steel nails in the wall. Number 4. The length of iron bar at 25 degrees Celsius is 10 meter. If the length coefficient of iron is 1.2 times 10 to the power of minus 5 per degree Celsius, what is the length of the iron bar at 80 degrees Celsius? Solution. Now, L0 is 10 meter, T1 is 25 degrees Celsius, T2 is 80 degrees Celsius, alpha is 1.2 times 10 to the power of minus 5 per degree Celsius, and as LT, the answer is LT equals to L0 bracket 1 plus alpha times delta T equals to 10 bracket 1 plus 1.2 times 10 to the power of minus 5 times 55. So LT equals to 10 bracket 1 plus 6.6 times 10 to the power of minus 4 equals to 10 plus 6.6 times 10 to the power of minus 3. So the answer is 10 plus 0.0066 meter. So when the iron at 80 degrees Celsius, its length becomes 10 meters plus 0.006 centimeter. Number 5. A piece of wire has a length of 2 meters at a temperature of 30 degrees Celsius, then heated until 80 degrees Celsius. If the coefficient of wire length expansion is 0.000019 per degree Celsius, determine A. the length of wire after heated, B. the increase in wire length. Solution. Now, L0 is 2 meters, T1 is 30 degrees Celsius, T2 is 80 degrees Celsius, alpha is 0.000019 per degree Celsius, or we can write 19.10 to the power of minus 6 per degree Celsius as A. LT and B. delta L. Based on the formula of LT, we can find delta T first. Delta T equals to T2 minus T1. 80 degrees Celsius minus 30 degrees Celsius equals to 50 degrees Celsius. LT equals to L0 bracket 1 plus alpha times delta T. LT equals to 2 meter bracket 1 plus 19 times 10 to the power of minus 6 times 50. So LT 2 times bracket 1 plus 19 times 10 to the power of minus 6 times 5.10 to the power of 1. So LT equals to 2 meter bracket 1 plus 95 times 10 to the power of minus 5. So LT equals to 2 meter bracket 1 plus 0.00095. So LT is 2 times 1.00095. So the answer is LT equals to 2.0019 meter. Now B, delta L. Delta L is LT minus L0. So delta L is 2.0019 minus 2. So the answer is delta L equals to 0.0019 meter. Number 6. A rod of wire has a length of 1 meter at a temperature of 25 degrees Celsius. Then the wire is heated until 125 degrees Celsius. So the length of wire becomes 1.0017 meter. Calculate coefficient of wire length expansion. The solution. Now L0 equals to 1 meter. LT equals to 1.0017 meter. T1 is 25 degrees Celsius and T2 is 125 degrees Celsius as alpha. So the answer is, first we find delta T equals to T2 minus T1, 125 degrees Celsius minus 25 degrees Celsius, so the answer is 100 degrees Celsius. Delta L is LT minus L0. Based on the formula of LT equals to L0 bracket 1 plus alpha times delta T. So 1.0017 meter equals to 1 meter bracket 1 plus alpha times 100 degrees Celsius. 1.0017 meter equals to 1 meter plus alpha times 100 degrees Celsius meter. 1.0017 minus 1 equals to alpha times 100. So 0.0017 equals to alpha times 100. So alpha is 17 times 10 to the power of minus 4 divided by 10 to the power of 2 per degree Celsius. Or we can write alpha equals to 17.10 to the power of minus 6 per degree Celsius. Number 7. Look at the bimetallic below. At first the bimetal was struck. When this bimetallic temperature increases, it looks like the picture. Which of the following statements is correct? A. The length expansion coefficient of metal A is bigger than metal B. B. The length expansion coefficient of metal A is smaller than metal B. C. The length expansion coefficient of metal A is equal to metal B. D. This phenomenon has nothing to do with the expansion coefficient of the two metals. And the answer is B. The length expansion coefficient of metal A is smaller than metal B because the metal bent toward the A. I think that's all for today. Thank you for your attention and God bless you.